Okay, so we're back. So we just want to look at the last couple of slides from this particular concept, looking at exponential functions with other bases. Before we go on to have a look at some examples, these are two important rules that you should copy down into your theory books, because it's talking about a real number can be written in as a power of e. So a, which is a constant, can be expressed as a power of e. So what do I have? I have a is the same as e to the power of log base ea, right? And then it goes on further to say that every exponential function, so a to the power of x is an exponential function, can be expressed as an exponential function base e. So a to the power of x, following from here, we end up with e to the power of x log base ea. All right, now you can probably see why that happens, but if not, have a think about it, and then if you can't figure it out, send a question to ask why this is the case. Okay, so let's just consider, for example, the constant constant 2. A constant, e.g. 2. And I want to write that as a power of e. All right, well, following the rule, this is the same as saying e to the power of log base e2. Okay, and then if I have 2 to the power of x, I can write it, this is an exponential function, I can express it as an exponential function base e, following the same idea, e, and what happens? I just have x log base e2. Okay, we need to be able to do this so that you can change things and it becomes easy to differentiate or to integrate later on. Okay, so just keep those things in mind. All right, so there's some of the questions that you were asked to do from the last exercise in the textbook. The only other one would be maybe 5 to the power of negative x. Well, that's the same idea, e to the power of negative x log base e2. All right, so they're the typical questions. Now, let's move on to differentiating these type of questions. So, the reference sheet. So, using the reference sheet, we're told that if y is equal to a to the power of f of x, then dy dx is equal to ln a. Okay, so this is exactly how it is on the reference sheet. If the derivative of your f of x. Okay, so the questions that are here on the slides, I think there are 3 of them. Differentiate. Number 1, y equals 2 to the power of x. So now I'm differentiating that. All right, now following this, you can see now that I can go straight into using the rule. There is an alternative method by using what we've just done, but if you're given the rule, you can apply it and it'll be a lot quicker. So the derivative of y equals 2 to the power of x, what do I end up with? Log base ea, my a is my 2. Okay, times the derivative of the power, well, that's just the derivative of x is 1, times my a to the power of f of x, right, which is, so that's just 2 to the power of x. All right, so the answer here becomes 2x log base e2. That's my dy dx. Okay, that's question number 1. Question number 2, just write that off. Question 2 is asking me to find the derivative of y equals 5 to the power of x. same idea, dy dx is equal to log base e5 times the derivative of the power, which is 1, times my a of f of x, which is 5 to the power x. So I end up with 5 to the power x log base e5. Alright, that's my dy dx. So hopefully you're getting the idea now how to apply this formula. Then part 3, it's a little bit more interesting. Well, question 3 is find the derivative of y equals 2 to the power of 3x plus 1. Okay, don't panic. It's the same idea. Dy dx equals, right? Let's think. That's my base. So it's log base e, so that's my a, I should say, which is 2, right? Times, now this is something that you need to think about, okay? I differentiate the power. So the derivative of 3x is 3 times my a of f of x, which is 2 to the power of 3x plus 1. I'm going to put that in brackets. Now, just go back to year 11 or log laws, which you would have revised recently, and then I end up with times 2 to the power of 3x plus 1. Remember, this 3, what can I do with this 3? Okay, think about it. Yes, you got it? I can bring it up to the top here. Okay, that I can rewrite this as log base e 2 to the power of 3 times, and I'm now going to leave out the multiplication sign. And I know, well, 2 to the power of 3 is 8, so I'm just going to fix it up a little bit. I'm going to write that first, and then log base e, or ln 8. And that is my dy dx. Okay? Alright, so hopefully you can see that there. Now, there is an alternative. That's if you like using the chain rule. The chain rule, you can say, well, if I let u equal to this,